Hello, I'm Isaku Yamahata, and I'm maintaining integration of OpenDaylight and OpenStack. OpenDaylight is one of the open source SDN platform, and it supports OpenStack. So you can use OpenStack with OpenDaylight, OpenStack Neutron and OpenDaylight. So, OpenDaylight manages a network element. So when we deploy the VM and we deploy OpenStack and we boot VMs, OpenDaylight manages OpenVSwitch on compute node and networking node. And networking-odl is a key component of OpenDaylight integration. Networking-odl provides many drivers for Neutron for various functionalities, L2, L3, and other advanced functionalities, L2 gateway, SFC service function chaining, and so on. And that team has been working on hard to improve its quality. Actually, networking-odl role is to maintain two status, Neutron status and OpenDaylight status in sync. And generally, to make two states in sync in distributed environment is a quite difficult task. So, before driver was very simple and easy. When user requests to create a new resource like Neutron network, subnet, port, and so on, networking-odl updates a state in Neutron state, which is in MySQL, and then push down those requests to OpenDaylight. And then OpenDaylight stores its information into its own data store. So it sounds very quite simple and easy task. And this works quite well for POC or your test on your laptop or desktop as all-in-one setup. However, it turns out this implementation is quite toy. It can't be used in a production environment because in a production environment, HA is a must. So in order to avoid a single point of failure, we have to deploy multiple instances of Neutron servers. So users can send their requests to any one of the Neutron servers. So one user request can send to one of the Neutron server instances, and another request can be sent to another Neutron servers. So there is a race condition. You can send for example, you can send a port up request to one of the Neutron servers, and you can send a port down request to another Neutron server. So each server simultaneously update Neutron DB and also simultaneously talks to OpenDaylight. So the two states, Neutron state and OpenDaylight state, can be easily out of sync. Neutron can be think port is up, but OpenDaylight can think port is down. This is a very bad situation. So the team has decided to introduce a new framework. Basically, it introduced a new DB table as an operation log. We call it a journal table. And also, we introduced a syncing thread inside Neutron servers. So basically, when users send a request to Neutron servers, new driver framework logs its operation into journal table, and also at the same time of the DB update in the same DB transaction. And after the DB transaction is committed, journal thread is kicked. And then journal thread scans journal DB and pick the oldest entry, and then push down its request to OpenDaylight. By using journal table, the order of request is guaranteed, so race condition is resolved in theory. And also, as a bonus, operation log provides a crash recovery capability. When neutron servers can crash at any time, so in theory, it is possible. Neutron DB is updated, and after Neutron DB is updated, but before sending a pushing down request to OpenDaylight, Neutron server can crash. In that case, also Neutron DB and OpenDaylight states can be out of sync. In that case, when Neutron server comes up again, journal thread can scan the journal table, and we can find uncompleted operations, so that unsync part can be replayed on a Neutron server startup. So basically, this idea seems very good, and that team has been working hard for a while. But for a while. However, there is a pros and cons. Its benefit is it provides a race. It resolves a race condition, and also it provides a crash recovery capability, and also it makes all operation asynchronous, and it provides many benefits. On the other hand, this is a quite complex solution, and it is quite difficult to debug. So in one word, bad point is that it's very complex, and the team has been working for a while, but we have still many things to do to finalize this new driver framework. Right now, it's working in some sense, but we have many things to improve. Okay, so here is a pointer to related information. So you can try it, new driver framework, and right now it's working quite well, but we'd like to fill many other issues. Okay, thank you.